Hi everyone, my name is Shamsaudi bin Shahrin and I'm gonna give a review on the article of organic chemistry in forensic world, use of organic compounds in forensic investigation. So the introduction is the forensic science is the general word for all scientific process utilized in criminal investigation such as then encoding, toxicology, serology, and ballistics. The gathering of physical evidence such as fingerprints, genetics, materials, and trace substances is a significant component of forensic research. First, I'm going to talk about the fingerprint recognition that is used and identified by the forensic scientists. Okay, there are three types of fingerprints, that is patent, plastic, and latent. Patent is fingerprint that are visible to the human eyes, that's usually imprinted on dust, walls, waters. So for the plastic is usually surface printed fingerprints that are visible in 3 dimensions. Usually means that the fingerprint is imprinted onto dirt or plastic, clay, or cloth. So lastly is the latent. Latent fingerprints cannot be seen with the naked eyes, but it is mostly composed with chemicals such as sweat, uh, fats, and proteins. So continuing, there are also Regis patterns. The Regis pattern has 3 levels. Level number 1 is the Regis details of the general flow of the Regis and the fingerprint pattern configurations. So on the second level is the Regis detail includes formations. The formation of the Regis on our fingerprints defined as ridge ending, bifurcation, dot, or combination thereof. On the level 3 of the ridge details is the more complex and includes all the dimensional attributes of a ridge that can be used to further identify the fingerprint more and such more detail. So these are the level 1 details of the Regis patterns. The major creases is there are 3 major creases, that is arch, whorl, and loop, and each one of them has specific creases patterns such as plain arch, dented arch, or whorl for plain whorl, double loop whorl, or loop, ulnar loop, or radial loop. So these are the level 2 details, Regis patterns. There are spurs that spurs from besides the ridges, overlapping the ridges, trifurcation, tri-junction of ridges, enclosure, the ridge is making a circle, a dot, basically a dot ridge or island ridges, and independent, long ridges that have no connection with any others ridges. The second thing I want to talk about is the fingerprints chemistry. The about the chemical substances that came out from our fingerprints and how to enhance the substances that are left by the fingerprints to make it more details and can be identified further. So here is the chemicals from the fingerprints. Fingerprints are composed of many chemical substances that helps forensic investigators to further identify the fingerprints such as the sweat, the amino acids, the fatty acids, proteins, cholesterols, all from the fingerprints. Fingerprints lose each of their chemical constituents at different rates. So these are the usefulness of the chemicals that can detect and identify fingerprints with chemistry. Number one is the visible fingerprints reagents like dihydrin. Dihydrin is the most widely used chemical reagent for the detection of latent fingerprints marks on porous surface such as paper and cardboards. Uh, and lipid sensitive reagents like oil red or and solvent black tea that are sensitive to amino acids. So number two is the Nile red and Nile blue, which collects fluorescent imprints, luminous fingerprints reagents. And the third one is the fingerprints impressions made with dual fingerprints reagents, such as the natural pigment genipin, are both visible and luminous. So in conclusion, organic chemistry is a crucial tool in forensic science since it's possible to recognize, examine, and interpret a variety of chemical compounds and materials used in chemical investigation. It is essential in preventing crimes from happening, supplying vital evidence in court, and guaranteeing that justice is done.